Hello, you are welcome to New Focus Approach to Mathematics Basic 9. This is the revised edition. And in this lesson, we want to learn set identities. We want to look at some of the rules that govern sets. This lesson can be found in page 50 of your book. Now, when we talk of set identities, like we said, we are looking at the rules. And so we have 5 different rules we want to consider, which will guide you in simplifying sets at the same time solving problems involving sets. Now, rule one says that if we have a set, okay, and we are multiplying two numbers and they are all under square roots, then we can easily write a separate square root for each of them, like root of AB can be the same as root A times root B. What it means is that if I give you, let's say, 2x under square root, this can easily be written as root of 2 separately, root of x separately. That's what it means. Again, if I have root of 6, I can easily write it root of 2 times root of 3. That is what it means. In future, you could be given a question like maybe square root of 6 times square root of 7, and it means that this can be multiplied together because they are all having square roots. So we know our 6 times 7 will give us root of 42, right? So that is that. But then be careful you don't say that root of A plus root of, or let me just do this, root of A plus root of B. Don't say this will give us A plus B altogether. No, this can never be. It works for only multiplication here, and it will work for this also division. Again, you can't also say that root of A minus root of B should give you root of A minus B altogether. No, this cannot be possible as well. And so this rule we are talking about is for only multiplication. When we come to division, yes, it works the same way, that if I have square root of A over B is the same as separating root A and root B. What it means is that if I have square root of, let's say, 9 over 25, I can easily write this as root of 9 separately root of 25. Of course, root of 9 can give me 3, while this one gives me 5 as well. And so this is what the second rule is trying to teach us. Let's look at the third rule. Third rule has to do with rationalization, okay, of the denominator. So if I have A over root of B, I can easily rationalize the denominator. What it means is that I'm trying to make the denominator, which is irrational, becomes rational. That is the whole idea. And so if I have A over root B, then I'll pick the denominator and multiply both the numerator and denominator by the same denominator. Of course, so that is what we have here. So this A over root B is the same as saying A over root B times root B over root B. And when I multiply A times B, I'll get A root B, and then root B times root B will just give me B. Or root B times root B is the same as saying root B all squared. And then the two cancel the root, giving us only B. So if I have, let's say, 3 divided by root 2, I can easily do this 3 over root 2 times root 2 over root 2. And when I simplify this, I'm going to have 3 root 2 over root 2 times root 2 will just give me 2. In that case, I've been able to make the denominator becoming a rational number. Now let's look at the rule number 4. Rule number 4 says that if I have say we have m root a plus or minus n root a, since the roots are of the same, we can add the coefficient and maintain square root of a. This is what it means. If it is minus 2, we'll subtract. So for example, if I have square root, let's say 3 root 4 plus, or let me make it root 5 so it doesn't become an exact number, plus 3, or let's say 4 root 5. Now since we have root 5 here, root 5 here. This will be equal to just adding 3 plus 4, which is 7, and maintaining root 5. That is what it means. Okay, that's what it means. And if it is minus 2 here, we just subtract and then we get the answer. Now the last rule also is about rationalization, but here we want to apply a principle called conjugate surd. Conjugate surd. You do this when you go to senior high school. But the conjugate surd simply means if I have x plus root of y, its conjugate become x minus root of y. If I have square root of 3 minus root of 5, the conjugate of this expression becomes root of 3 plus root of 5. That is what it means. So we use that conjugate to rationalize denominators of this sort. And so what it means here also is that if I have p over this, then I can maintain p over this and multiply both the numerator and denominator by the same conjugate, which is x minus y root q over x minus y root q. What it means is that in future, if I give you, let's say, 3 divided by 4 plus root 3, this is the same as writing 3 over 4 plus root 3 and multiply both the numerator, which is 4 minus root 3 over 4 minus root 3. So I just pick the denominator and then change it to its conjugate and multiply both numerator and denominator by the same conjugate. So I can now simplify this work and get my answer. Okay, let me give you another example. Say I have maybe root of 5 over root 4 minus maybe 3 root 2. Okay, this I can write as root 5 over the same 4 minus 3 root 2. Then I'll multiply both the numerator here by the conjugate 4 plus 3 root 2 over the same 4 plus 3 root 2. Then I simplify. When I simplify, that becomes the result. We'll solve more questions like this in our next video so that you know how to simplify. So these are the rules or the set identities that we have for you for now. This is for junior high school. As you progress to senior high school, you'll be doing more examples under this. Thanks so much for watching.